Okay, now we're ready. Let's get started, okay? So, today we're going to take a look at some capabilities of Python to visualize data. In other words, to plot charts, right? So, you have the Jupyter notebooks running on your machine, right? So, well, I'm going to show you how to do it from, for example, if you're not in the lab, right? And if you want to run it on your machine, then here's what you need to do, okay? Go to jupyter.org, the website that we used in a couple of previous classes, right? And if you scroll it in the kind of in the middle of the page, this is what we've done so far, right? Try it in your browser, correct? Try it in your browser. But you have to go ahead and install the notebook on your machine. So after that, yeah, that's what you needed to do, okay? And it has instructions where to click, what packages to download, which packages to run. So essentially, it tells you, steps how to install it. So it requires certain software to be installed on your machine to be able.
Is it going to do it on our own computers, or are you going to do it here?
No, on your own computer. Over here, you just come in and you type Jupyter Notebooks in the search. Well, this is what I'm going to do, right? So search Jupyter Notebook, and when I'm clicking on this thing, it's supposed to actually run in the local browser. Hold on. Close this one. Jupyter Notebook. Takes some time to load. There you go. So what you should see when you run it from the prompt command, right? Just typing Jupyter Notebook and clicking OK. It will open up in your browser. So this is what you should see in front of you, correct? That's pretty much what you see. But if you look at the URL, what does the URL tell you? Localhost 8888/3, right? Localhost means it's running on your machine. Okay? It's in the browser, but the code actually is executing here on your machine. The previous couple of classes when we ran the code, it was running on the server, right? That's why I could show you like simple stuff, how to define variables, how to write functions, how to do the for loops, right? But we couldn't do anything with data because the code is not running on your machine. It's just in the browser. The browser tells you what's going on the server, right? Now your machine is the server, okay? The code is running here locally. And how can you tell? It doesn't say Jupyter try.jupyter.org, blah, 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 right? It says localhost. That means it's here on the machine, okay? So let's go ahead and go to this button, new, right? And you should see a list of things, right? One of them should tell you Python. Yours says probably Python 3, right? Yeah, mine says Python 2, so I'm going to go ahead and run Python 2. Okay, and that's what you should see.
Let's get it.
Yep.
I have mine. It's a split, but I can still have windows, and stuff is added to Jupyter Notebook as we progress.
Let me see.
It's not like it's just something that I like to see happen. Just because, like,
Yeah, that's cool. Okay, cool. All right. Well, first thing, let me tell you guys that what's the power behind Jupyter or Python for that matter, right? Jupyter is just an online editor where you can run different programs in different languages, right? What's the power of Python and the power of R? Why are they so popular? That's because in order to analyze the data, we have already a bunch of software written, okay? So we don't have to create the code in order to construct the graphs, for example, or run the tree analysis or regression analysis, anything, okay? It's been done already. And all this code is packaged in form of libraries, okay? So library, you can think of library as a file, okay, with with a bunch of code, with functions essentially, and we can call on these functions to do things for us, to do the data analysis. But before we do that, we need to connect to these libraries, right? And that is done in Python by importing the libraries, okay? So the library that we're going to use for our intents and purposes is called Seaborn, okay? Seaborn is a very powerful visualization library that's supplied with Python. So in order to import that, go ahead and type literally import, the word import, and then type the word Seaborn, and I'm going to give it an alias. So type Seaborn as, and the standard way how Python community does that is they call Seaborn SNS, so kind of abbreviation. There is like an anecdote behind why is it SNS, it's Seaborn, so why do you abbreviate it as an S? It doesn't matter, okay? So import Seaborn as SNS, and then go ahead and click on the button run, and you will see there is an asterisk, right?
Yeah.
Yours has an asterisk, right?
Yeah.
And after that it turns into a number, right?
No.
Still an asterisk?
Yeah.
Tell me when it turns into a number.
Not yet.
Oh yeah.
I don't think it's ever turned into.
No, it will eventually. I tried it earlier today on one of these machines, it did. Asterisk really means that the code is still running, okay? It did, yeah. And when it turns into a number means done, okay? So now we have linked to our browser, okay, the graphical library, okay? All right, so now that we have a graphical library, let's try visualizing some data sets, okay? One thing that I wanted to tell you is when you install Python and Anaconda on your computers, it actually not only comes with the libraries of functions that do the graphing for you, but it also comes with the data set, okay? Not one data set, multiple data sets, okay? It's kind of test data sets that were supplied. So let's go ahead and read these data sets into the memory, okay? So one of them, for example, is tips, okay? So let's call this data set quite literally tips, okay? So I'm going to define a variable thereby called tips, okay? And I'm going to say tips equal this library which I just linked, SNS. Then I put a dot under that, okay, after SNS. That means in the library SNS, call the function. And the function is called load underscore data set, okay? So load data set, and then after that, put parentheses, and inside parentheses type quote unquote tips, okay? Tips. Just like that. Okay? So we don't even have to specify where is this data set located. It's somewhere on the computer, right? When the Python was installed on my machine, it was installed together with data sets in certain directories, so the Python knows where to find it, okay? And after that, go ahead and click Run button. And do you see the number 2 after that? That means that the code actually executed, and now we have loaded the data set, okay? So it found the library, not the library, the data set called tips, okay? And it loaded that data set into the variable, well, which we call tips. We could call it anything, right? We could call it X, Y, Z, anything really. Okay, so let's see what's inside this thing, right? So go ahead and just type tips and run it, okay?
You'll see SNS.
No, just show what's inside the variable, okay? And this is something that you should see, right? A table.
What? Wait, hold up.
Yeah.
So when you import a Seaborn, is that something that's already in the computer that is supported? How did it, so import tells it to search in the folder and find.
And link the library, right? So essentially what's happening right now is we have the Python running on the machine, right? Python as the interpreter, so to speak. It's a program really, right? That reads your code and executes it line by line, okay? So it's installed on the machine. But as we want to call on some of these commands, for example, this one, okay? Which we just ran. says SNS. It means that in order for us to use this function, load dataset, it's actually defined in the library Seaborn. Okay, so therefore you have to find the library, a file with literally a bunch of functions, and include that in the Python which is running, right? So that's why we said import Seaborn. So Seaborn is installed as well. Okay, so when we say import, the reason why it took it so long, the asterisk thing, right, is because it was reading that into the memory and including that as the part of the running program, right? And after that, everything which is inside of this library is available to us. So that's what we did. We said, use the library, and inside of that there is a function which reads the data file. That's what we did, right? It looks up the file, opens it up, reads it line by line, and stores everything in the variable tips. And now we just display the variable tips, okay? Now, if you would guess, what does this file include? You would have to guess. Well, yeah, what's dataset about?
Tips.
Tips?
Tips at a restaurant.
Tips at the restaurant, right? Total bill, and then how much tip was left, and then was the waiter a female or a male, right? Smoker or not, that's probably a customer, right? Was customer smoking or not smoking, okay? What day of the week? Sunday, and then I'm sure there are some other days. Time, right?
Why is there a break in between? Is that it skipping?
This break right there?
It just means, okay, we're going to show you the beginning and the end of the day.
Yeah, so it shows, as you see, first 30 records and the last probably 30 records, right? And it says, total we have 244 records in 7 columns, right? Okay, cool. All right, so let's go ahead and visualize things, all right? So now this time around, I believe I have to do something extra. In your case, it's going to run seamlessly. So let's do the box plot, okay? You remember what the box plot is, right? Box and whiskers plot, the other way to describe it. Okay, so here's what I'm going to do. I'm going to say, again, the ability to plot the box plot is included inside the Seaborn library. It's a graphical library, okay? It has a bunch of functions which basically create plots for you. So how do we invoke or call on these functions? Very simple, right? We type the library SNS. So that's what I'm going to do. Type the library name, SNS. That's Seaborn, right? We included that as SNS. And then I'm going to put comma. I'm going to say inside this library, let's find boxplot function, okay? And the boxplot function, actually, you know what? Let's not even do that. Let me show you how to find help, okay? Very easy. Suppose I want to plot a box plot, right? And I don't know how to do it. So all I have to do is say help, okay? And then open and close the parentheses. And inside parentheses, I want to provide what exactly I'm looking for, right? So if I type box plot, see what happens. No, box plot is fine, no quotations, but it will probably crap out on you, right? Like that. It will say, I don't understand what the box plot is. Remember, we included that as a part of the library, right? So it should be what? SNS.boxplot. So library SNS, and inside this library there is a function boxplot, right? So now let's run it, and it gives you the help, right? It says this is how to use this function, okay? It takes x as, well, your horizontal variable, y as your vertical variable, hue as the color, right? And the data, etc., okay? So, well, let me go ahead and use this thing, right? So I'm going to type in my next line. So this is essentially information about any function, right? So you can type help on this function and it will tell you what variables it takes, and if you scroll down actually, it will even show you some of the examples, right? So this one, for example, you can say AX equals SNS boxplot, blah, 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 right? Okay, so let's go ahead and do that. In the next line, I'm going to type X. X is my name of the variable, right? It will contain the object, so to speak, right? And I'm going to say, go ahead and call SNS.boxplot. Okay? And inside the boxplot, here's what I'm going to do. I will call I will plot out of these variables, right? So how many variables do I have in my file? I have, what, 7 of them, right? Bill, tip, sex, smoker, daytime, and size. Well, let me plot the total bill. Okay? So in your function, sns.boxplot, go ahead and type. As an x, I'm going to use, and now I need to use quotations, quote unquote, total, and make sure that you spell the variable correctly. It has an underscore, okay? Total underscore bill. Say again?
What does the X stand for?
Well, horizontal axis, right? Well, actually, take a look. What happens if you put y instead of x, right?
We'll flip it.
It will flip it, right? But now, I'm not telling where. So I'm saying to the function, plot the variable Boxplot, total bill, right? But where is it coming from? Well, I recorded all things inside my variable. What's the variable name? Tips, right? Remember when I read the file, load the data into the variable tips, right? So here, after I say horizontally plot me the variable total bill, and the data, where it's coming from, supposed to be tips. Okay? Just like that. Go ahead and run it. And in my case, it didn't show anything. Do you see? Do you see it? Right? It's probably because I need. Hold on. Don't do what I'm going to do. Okay? I need to import another library. I need to import matplotlib.pyplot as plt.
It said error.
Well, if it says error, that means that you misspelled something. Okay? AB was able to run it, back was able to run it, right? Okay. So in order for me to show this thing, I need to tell plt.show. Yeah. That's what you see, correct? This is what you see. Yeah. So I had to do an extra thing. So mine executed, right?
Same.
Yeah. And after that, it was recorded into the variable, but to display it, I had to actually explicitly say show the plot. So everybody got the plot showing? Yep. Okay, cool. Now let's kind of mess around with this thing, right? So what if I change x into y? Right. Go back to your plot, and instead of saying x equals total bill, go ahead and say y equals total bill. Can you guess what will happen?
It'll flip it.
It'll flip it, right? So, yep. Instead of horizontally along the x direction, it'll show it vertically along the y direction. Okay?
I like the other one.
Yeah, let's flip it back, right? So, x, and I need to rerun it. Okay. Yeah, so what do we see? We see that median tip is what? Around, what would your guess be? Median, oh, it's not a tip, it's a bill, right? Median bill is somewhere around $18 or something like that, right? And the boundary for the usual bills, right, is around $40, and anything above $40 is an outlier, right? Okay. Let's try something else, actually. What if I want to show multiple distributions simultaneously? So this is just a distribution of all total bills, like everything summarized, right? By the gender of the waiter and waitress, by day of the week, smoker, non-smoker, they're all included. What if I want to break them down by the day of the week? Okay, can I separate them? So let's try that. So I'm going to add, look at the data. You see the column which says day. And some days are Sundays. Then I scroll down, then there is Saturday, and there is Friday. Okay, so how about that? I'm going to put after x, I'm going to add y equals day. And make sure that they're all separated by commas, right? Because these are arguments that you are sending to the function, okay? They have to be comma separated. So horizontally, I plot the total bill, but I want to break it vertically by the day, right? Summarize it by Sunday, Saturday, Friday, etc., etc. So if I run it, it executes, and yours probably is updated, right? Did it update?
Y equals
Y equals day. So you should see something like this, right? Do you see? Do you have the same thing?
I messed it up.
You probably did. So make sure that your syntax is like this, okay? So vertically break it down by day, horizontally plot total bill. So now my box plot separated data into buckets, right? Sunday, Saturday, Friday, etc., etc. So what do we see over time? On Thursdays and on Fridays, distributions are probably about the same, right? Let's check, okay? But Saturday, distribution starts to shift a little bit to the right, okay? Mean starts to move, and on Sunday it's even higher. So on the weekend, people tend to spend what? More at the restaurants, right, if they go. And you can see that the outliers are also getting further and further away, right? Make sense?
Yeah.
Is that cool, or what? Yay. Okay, so let's do another one, right? I don't see the next line showing, so I'm going to add that. So click on the plus sign, and the next line will show up, okay? So this is one of the most popular plots, right, that we can do with any software, really, be it Python or Jump or anything else. Okay, so let's do another one. Let me show you a plot of the distribution, which is a little bit more, well, descriptive, probably a little bit more detailed than the box plot. See, box plots are built around something that's called a 5-number summary, right? What's 5-number summary? You have your mean right there. You have your first quartile, median, second quartile, right? Third quartile, and your max right there, right? It's either cutoff for your whisker or the highest number out there, right? It's built around 5-number summary, okay? So really, you don't know how everything else is distributed, right? Inside the whiskers, inside your second quartile, third quartile, fourth quartile, right? So you have no visibility. But that's actually alleviated by something that's called a violin plot, okay? Because it looks like a violin, like a musical instrument. So let's go ahead and do that. And it's located inside which library, can you guess? Seaborn, right? So we have to say, again, I'm going to say, let me call it differently now, okay? I'm going to call it AY equals, I'm going to call on the Seaborn library, SNS, because that's how I abbreviated that, right? And then I'm going to type literally violin plot, okay? Violin plot. And then open, close the parentheses. And let me do it differently actually now, okay? Well, one thing that I forgot to tell you is this, okay? Let me actually go back for a second. When we run this line of code which says tips equal SNS load dataset blah blah blah, we created a variable inside my program which is called tips, right? And inside this variable tips, I got the entire dataset. In Python and in R, very similar language, right, for statistical calculations, the variable tips in which you read the dataset is called DataFrame, okay? And you can see that it's very much like a table, right, with columns and records, okay? So your columns represent what? Your columns represent variables, and your records represent every individual case, right? Every individual record, like one customer in our case, okay? Now, what's cool about DataFrame is that every column can contain its own data type. What do I mean by that? True or false? The first column where it says total bill is a numerical column. It is, right? It's just a bunch of numbers. Second column, tips, is also a numerical column, right? Next column, which says sex, female and male. Not numerical, right? What type of the column is that? What do you think? Well, categorical string, right? It's a string. True, it's categorical, but the type of the data which is stored is string, okay? So when you're reading the data inside the data frame, it will actually keep, it can keep every column with a different data type. So it's not all text. Some things can be currencies, some things can be strings, some things can be integers, some things can be decimals, like our numbers are decimals, right? Floating point numbers, okay? Some things can be true or false, or Boolean. Sometimes it's called also Boolean variable, okay? So that's what's cool about DataFrame. It keeps the data sets separate. So let's go back to our violin plot, right? Here is how I can actually tell the function which data do I want to plot. One thing that I can do is just go ahead and say, you know, I want my x to be, again, quote unquote, total bill, total underscore bill, okay? And after that, I'll tell it my data is supposed to be tips, right? And let's go ahead and run this thing. So, very similar, right? I call it very similar to the Boxplot. Did it show on your computer? Yeah, on mine it didn't because, because I need to call plt.show, right? plt.show. Yeah, and then it shows up, okay? So, the violin plot, you can see, is a little bit more detailed, right, than my box. So, essentially, it's showing me the same thing, right? If you look at my original, oh, I don't have it anymore, right? So, how about I rerun it over here? I remove the breakdown by the day, okay? And again, make it into one plot, right? So, my violin plot basically shows me exactly the same thing, right, but more detailed, okay? So, these two essentially are showing you exactly the same information. You can see that my outlier on the far right is exactly the same, okay? This is where my minimum is, but it shows you exactly the distribution everywhere, okay? And it's not a traditional histogram. You all know histogram, right? It's a bar plot, right? So, essentially, you can think of violin plot as the smooth histogram, okay? So, you don't have all these bars, but instead of that, the tops of the bars are connected with a smooth line, and that basically gives you the distribution, like a graphical representation of where is the majority of points lie, right? It shows you where is the highest density of the point, okay? So that's a violin plot. And again, all I can do, if I want to break it down by the day, what do? Can you guess? Do the same thing, right? So I say y equals to the day, right? Variable day, and the same data set, okay? So now, if I run it, oopsie, what did I do? Okay, I put extra thing. Yeah, it gives me 3 distributions on 3 different days, right? 3 violin plots. Did you get it? Okay, what I wanted to show you is how can I plot this alternatively, okay? So, let's go back to the command which gives me a violin plot, okay? So, go ahead and erase data equals tips, okay? So, instead of that, here's what I'm going to do. I'm going to say that the variable x that you are going to plot is going to be tips data, okay? And inside the tips data, you're going to pick up the column total bills, okay? I do that by, oops, hold on, I put an extra square bracket in there. So this is how I do it, okay? I'm going to say x, what you want to plot horizontally, your variable x is going to be data tips, right? That's the name of my variable which contains my data set, right? And inside this data, you pick the variable with the name total underscore bills, okay? So you say tips, that's the name of your data set, then square brackets, and inside the square brackets in the quotation, the name of your column. Okay? That's another way to do it. So the result is the same. Okay? So, and if I go ahead and rerun it, then this violin plot shows up. Okay? How are we doing? Good? All right. Looks like we're out of time for today, right? So let's stop right here. On Friday, I'm going to show you a few more plots, right? Graphing capabilities of Python. And after that, we'll start actually talking about models, right? Some of the models. Okay.